Howdy and good day. We're in Algebra covering PO10 Part 1, multi-step equations. But before we get to that, we're going to go back and correct PO9 where we covered two-step equations. Because as you'll see in PO10, two-step equations are very much your friend when it comes to equation solving. I realized that going over and correcting and recording, I want to make it as efficient as possible, which means that I have to do the homework too, which is kind of lame, but here we are. I did it. So the first one, add 4, divide by 12, n ends up being 5. Second one is negative 18. Then we have 4.5. And the last one in that first row is 9. Do we have the trifolds figured out? Okay. Those that are sitting to a table, you do need your trifold up. So, second row, first one, n is 50, then 54, 1/2 or 0.5, either value is fine, and then 99 for the last one. Okay, there were a couple of them on here were my attempt to troll you and try and get you to make mistakes. So hopefully you successfully avoided them. The first one was the last one in that top row there. N divided by 3 plus 12 equals 15. Once you subtract 12 from both sides, which is the correct first step, you get n divided by 3 equals 3. And your brain, which is wired to recognize and make and execute connections, sees the division, sees the 2 3s, and perhaps your first thought, if even for a fleeting moment, was, oh, the answer is 1, right? Did anyone fall for that?
No.
Oh, no? Well, you're good. Because the correct way to solve this would be to multiply both sides by 3, and n ends up being 9. And if you did put 1, hopefully you would have checked yourself and caught yourself when you plugged it back in to the equation, you saw that it would not work. Okay. However, 9 does, because 9 divided by 3 is 3. 3 plus 12 is 15. The second one, similar thing here, second row. Second one, n divided by 18 plus 2. When you subtract 2 from both sides, get n divided by 18 equals 3. Your brain might think 6 because it sees the 18, the 3 division, but multiplying both sides by 18, which is the opposite operation of dividing by 18, and we get 54. And then the very next one, when you add 18 to both sides, and you get 18n equals positive 9. If you put 2, well, 18 divided by 9 equals 2, but the correct way to solve this would be divide both sides by 18, and 9/18 is where we get the value of 1/2. So those are 3 where common mistakes, but hopefully by showing your work, checking your work, you avoided them. Okay. Questions on those 8? Okay. The 2 word problems down at the bottom. What expression did you write for the first one, where you've got these 30 baseball cards from your parents, and then you and 3 other people are going to a store, and however many cards you buy from the store, you will divide evenly among the 4 of you? Caroline. Sorry, I did.
30 plus x divided by 4.
Is that 30 plus x like in the numerator of the fraction, or is it separate? Good. Okay. So you've got 30 plus x divided by 4. You could also write this as x divided by 4 plus 30. Or, since dividing by 4 is the same as multiplying by 1/4, you could even have 1/4 times x plus 30. Any of those 3 ways would be correct. But yeah, you are taking what you get from the store, dividing by 4, and then adding the 30 that you got from your parents. So if you buy 40 cards, you'll plug that in to be 40 divided by 4 plus 30, or 10 plus 30. You'll have 40 cards in your collection. The next one, you end up with 54 cards in your collection. And the last one, 86 cards in your collection. Olivia.
So what the like expression? I had the four on top.
So that would say that you've got 4 cards and you're dividing them among how many people are in your group. Or I said it backwards. You have 4 people in your group and those 4 people are being divided into how many cards you're buying.
Yeah, but I still got the same answer.
You shouldn't have, because if you plug in 40 here, you get 4 40ths, right? And 4 40ths, which is 1/10, or 0.1 plus 30, the solution of that is 30.1. So you may have written it that way, but when you calculated it correctly, if that's any consolation. So, okay. How about the expression for the second one? Yeah.
2,117 plus 64.
Good. Doesn't matter. You can put it wherever you want. But 2,117 plus 64n, you could write that the other way, 64n plus 2,117. But yeah, that 2,117 is your constant because that's what the pressure is at the surface, right? That's not changing. Whether you dive 10 feet or 100 feet, it's still that amount of pressure at the surface. Okay. Guys. That's it. And then that word per, 64 pounds per square foot, okay, there's that rate there, right? So if you go down 10 feet, you should get 2,757. 25 feet is 3,717. And 150 feet is 11,717. Okay? Those are your 3 answers for that one. Questions on this page? No? All right. I checked the Google question form. There weren't any questions there. Just as a reminder, if there's anything that pops up while you're doing the homework or you run out of time or whatever, you can ask it there. It's posted in Google Classroom along with the video link, and I'll be sure to cover it. But PO10 is where we're headed next, and this covers all the multi-step equation situations that you might come across. Okay, all those things where it's not written as a 2-step equation, there's something else that you need to do first. And one of the situations we're going to talk about today is combining like terms. Okay? And combining like terms, the goal is to simplify the equation to make a 2-step equation. The goal is to simplify the equation to make a 2-step equation. Simplify the equation to make a 2-step equation. The 2-step equation hopefully is going to become like your comfort zone. Like you get so comfortable solving that when you get there, it's just second nature. Constant, coefficient, done, right? But with combining like terms, does anyone have an aunt or an uncle that whenever he or she tells a story, it just goes on and full of details that really aren't necessary or you care about, or is that just me? That's just me. Okay. Well, the equations in the combining like terms are kind of like that. You know, it says 9x minus 4x plus 3 equals 43. What can we combine here just to shorten the equation and simplify it? Make it simpler. Yeah. 9x and negative 4x. Okay. Make sure you include that sign there. Right? Because if you have 9 x's and you subtract 4 of those x's, how many x's do you have left? 5 of them. Okay? No need to turn around. Nothing on his face or back there will be on the test, but this will here. So let's just focus up here. All right. So we get 5x plus 3 equals 43. Okay. Kind of like with adding and subtracting fractions, you can only combine things that have that same variable. 9x's minus 4x's gives us 5x's. That variable doesn't change. Why can't we add 5x and 3 to get 8x? Why is that not mathematically legal? Hand next time. Yeah.
Same thing.
Right. 3 doesn't have an x. Okay. If we were to add those to get 8x, we'd be breaking the order of operations because we have to get that product of 5 and x before we can do any adding. Okay. So, but we're in our two-step equation. So we'd start by subtracting 3 from both sides. 5x is 40. Divide by 5 and x equals 8. Okay. How about the second one? What can we combine in that equation? Kate. 8n and negative 11n. What does that give us? How many n's do we have? Olivia? Negative 3. Just 8 minus 11. Negative 3n plus 2 equals 29. We've simplified, and now we got our two-step equation. Notice how we don't use opposite operations here to combine the like terms. I sometimes see that happen. We don't add 11 to 8 to get 19n. We just take it as it's written here. And the reason why is because we're not moving anything from one side of the equation to the other. Everything's staying location-wise where it's at. So we only use opposite operations when we actually move something. Question? Sure, yes. You do need to check it. And I didn't show it here, but what you do is take this, plug it back into the original equation, just like you did on PO9. You may use a calculator on this test, yes. Okay. So subtract 2 from both sides. Negative 3n equals 27. Divided by negative 3, n equals 9. I heard someone mutter under their breath, what's the point of... What was that?
Well, I said, what's the point of doing this if in the test you just put in your calculator and you write it down?
Because you can't type this into your calculator.
Oh, shoot, never mind.
And I mean, it's, so you can use the calculator to help with the calculations, but the process of how to solve it, your calculator isn't going to do for you.
I didn't think
Okay.
that through before I asked it.
There is the old, just kind of guess and check method, pick things and see what sticks, but that not only takes time, but if, some math teacher were to make an answer, something like 7/12, good luck guessing and checking that, right? So calculators are a tool to help, but we certainly do need the process also. In that last one there, what can we combine? Give me some like terms, Alan. What are some like terms that we can combine there? Sorry? Negative 10, negative 2. Okay. What does that give us? How many n's does that give us in all? Negative 12. What else can we combine? Kate? 7 and 3. Positive 7, positive 3. They're both constants. Okay. And so that gives us positive 10. And we are at our two-step equation to go ahead and solve. Okay. Why don't we problem solve this? Finn, why don't you come sit here? That way you can put that down. You don't need it up. Christopher, you can put that down. You don't need it up. And maybe if you keep some of your stuff on the floor so it's not all over the desk, that would help too. Okay. So subtract 10 from both sides. Negative 12n equals negative 132. Divide both sides by negative 12, and we get n to be positive 11. Okay. Any questions on the combining of like terms? Yes? Same way that I asked you to do in PO9. Yep, plug it back in. Just make sure it works. That's where the calculator really comes in handy, is the checking piece of it. Because once you know what n is, then you can just put this whole thing in there, with the value plugged in for n, and and your calculator will do that entire calculation for
So
you.
how'd you get 12?
Negative 10 minus 2
Oh.
gives us a negative 12 there. Okay? And the 7 and 3, positive 7, positive 3, both constants, gave us positive 10 as our constant there. So it's just looking at coefficients, looking at constants, and combining them. Questions on this? Okay. The second method or second type we're going to talk about today is the distributive property. And the distributive property, you'll know you're dealing with it when you see these parentheses, right? And I'm going to preface this, Matthew, question? Sorry? Sure. I'm going to preface this by saying there are other ways to get rid of parentheses other than the distributive property. Okay, so if you bring this home and your parents look over your shoulder, or your siblings or friends or whatever, and say, "Why are you doing that? Why don't you just do this?" Okay, there are other ways. However, I want you to learn the distributive property, so I'm going to ask you to do it this way today. Okay, this way today, and the goal is to get rid of the parentheses. To create for ourselves a two-step equation. Okay? Yeah. To get rid of parentheses to create a two-step equation. To get rid of parentheses to create a two-step equation. So in the first one here, 7 times 3n minus 5, what am I going to be distributing into the parentheses?
-1.
The first one?
Wrong one. It's 7.
It is 7, yes. Okay. And what operation are we using when we distribute that 7 into the parentheses, Nick? We're multiplying, right? What this is saying, as it's written here, is we have 7 groups of 3n minus 5. Okay, we are taking 3n minus 5 7 times. Mathematically, that's the same thing as taking 7 groups of 3n, which is 21n, and then 7 groups of negative 5, or 7 negative 5s, which is negative 35. Okay, and then that equals 7. Now, if you're thinking to yourself, well, wait a minute, why can we combine the 7 and the 3n there? That 7 doesn't have an n. Didn't you just say it has to have the same variable? Well, like fractions, when you multiply and divide, that whole common denominator thing doesn't apply. Same thing here. Okay, the rules are different for multiplying and dividing than adding and subtracting. But now that we're at our two-step equation, add 35 to both sides, divide by our coefficient, and we get 2 as a value for n. Okay. To check it, I've got room here. So just like we did before, we're going to plug that 2 back into the equation. 3 times 2 is 6. Subtract 5 from that, we get 1. That's what's in our parentheses. And then 1 times 7, multiplied by the coefficient, we get 7 as an answer. What are we distributing in the second one? This is me again trying to troll you. Mackenzie? Oh, good. -2. Yeah, that sign belongs to it. Okay? And that 7 we're not going to use yet. In a different class, someone suggested that we distribute 5 into the parentheses. Subtract 7 and 2 first to get 5 and then put that in. Why is that mathematically illegal? Luke? Perm does, right? Right. This multiplication has to be done before we do any addition or subtraction. So 7 just drops down. -2 times n is -2n. -2 times -6 is a positive 12. And that equals 39. How do you do that? Are we at a two-step equation yet? We are not. Because we have a lot of numbers. Because we got stuff that we can combine, right? We got like terms there. 7 and 12, both being constants, we can combine them to get 19, and negative 2n plus 19 equals 39 is our two-step equation. That 39 doesn't change at all throughout this entire process because we're not moving anything over. We're just dealing with that left side. Okay? Again, multi-step, right? There's stuff that we have to do first. But now that we're at this point, subtract 19 from both sides. Negative 2n equals 20. Opposite operations, divide by negative 2. And n equals negative 10. Good. Lily, since you answered this question once already before, what are we going to distribute into the last one? A negative 1. Yes. It's not written, but it's there, that negative 1 as the coefficient to the parentheses. The 3t just drops down. And really, distributing in a negative 1, all it does is it changes the signs. Right? Negative 1 times 8 is a negative 8. Negative 1 times negative 2t is a positive 2t. And that equals 12. It's really, really easy to lose signs throughout this entire process. That's why showing every step, showing the work, not trying to do too much in your head, writing everything down, it's going to be really, really helpful here. Are we ready to solve this, or is there stuff we can do?
We can combine like terms.
What terms can we combine?
2t and 3.
2t and 3t. 5t minus 8 equals 12. And here we have our two-step equation. Start by adding 8 to both sides. 5t equals 20. Divide by 5. Ooh, that's a weird t. Whew. T equals 4.
That's an interesting thing.
It is. Okay. Questions on any of this? Review?
Some mixed answers there.
Yeah. Okay. For homework for tomorrow, I just want you to have a little practice with these two processes here. So only 7 for you to do. I'll wait till people are done writing. I'm going to scroll down and identify which ones I'd like you to do on the PO10 part 2. So skip the entire next page, flip one more over to where you've got like 12 equations written there or something like that, 15, whatever it is. Okay. And I'd like you to do, we'll cover variables on both sides tomorrow, but just mark these off. This first one, so first row, first one. First row, second one. Third row, second one. Second row, third one, sorry. Sorry. So 3 of the first 6, 2 in the first row, 1 in the second row. Nope. I said only 7. You're only getting 7. This is not too bad. 7. And then those first 3 were with combining like terms, and then with the distributive property, that one, that one, that one, and that one. It's on the same page, just a little bit further down. So 7 in all. The starred ones are the ones you do. The first 3 are with combining like terms. The last 4 are with the distributive property.
Having to solve problems, that's really scary.
Okay. Homework for tomorrow. We'll go over them then. That, folks, is how you math.